Hey everyone, it's Nol, and in this lesson, we will make a Mario-themed music using LED and buzzer. The first thing is to prepare the Arduino Sensor Kit and connect the Grove Base Shield to the Arduino Uno. Plug in the Grove buzzer to the pin marked D5 in the Grove Base Shield and the Grove LED pin to D6. Connect the Arduino Uno to the computer, open the Arduino IDE, and proceed to create a new sketch. First, we define the pitches note values. Let's create a file named pitches.h. You need to go to this website and copy the pitches note defined constants. Paste this in your pitches.h file. So you can go ahead and pause this video. The link can be found in the description. Once that's done, go back to your sketch and include the pitches file we created earlier. Then, we define the buzzer pin and the LED pin. The buzzer pin is set to 5, while the LED pin is set to 6. Proceed to the setup function. In the setup function, we will be defining the pin modes for our buzzer pin and our LED pin. Both are set to output. So that's pin mode buzzer pin output, pin mode LED pin output. Now, let's create a buzz function. This will handle the playing of the note with the target pin as your buzzer pin, frequency as the note, and length as a note duration. Turn on the LED to sync with the tone. This is using digital write LED pin high. We then calculate the delay value between transitions. The delay will be 1 second worth of microseconds, divided by the frequency and split in half since there are 2 phases in each cycle. So this is presented by the formula long delay value variable. Calculate the number of cycles for proper timing. Multiply frequency with the duration per seconds to get number of cycles. Now let's play the tone within the calculated number of cycles. So this is presented using the for statement. Write the buzzer pin set to high to push out the diaphragm to play the tone. We also create a delay within the calculated delay value. So that's delay microseconds, delay value. Then, set the buzzer pin to low using digital write. This pulls back the diaphragm to stop playing a tone. We also add a delay in microseconds. Turn off the LED to sync with the tone. That's digital write, LED pin low. So let's create the play tone function. This function is to play the array of notes with the array of durations. Tone melody is for the array notes. Tone melody size is for the array note melody size. And the tone tempo is for the array of notes during the duration. Next, loop the array of notes. This is presented by the for statement. And to calculate the note's duration, we use the formula below. We then call the buzz function to play the note. Set the pin to buzzer pin, the note, and the note duration. Also, calculate the pause between the next note. The calibrated pause will be 30% added to the note duration. Upon calling the buzz function, we must set the needed parameters with zero note value to stop the note playing and still within note duration. Now go to this website. This website already has Mario theme melody and tempos. Copy the array variable melody and tempo of Mario theme and the underworld Mario theme. You can go ahead and pause this video. Copy the link below or input the URL to your browser. Now that you've got it, paste it above the setup function. We then go to the main function, or the void loop. Let's calculate the size of the melody array of the Mario theme. We introduce the variable tone melody size. Now call the playTone function. This plays the array melody notes of Mario theme. Input the needed parameters. These are the Mario theme melody notes, melody note size, and the melody tempo. These are set from the following variables. So play it again to make the Mario theme longer. So type the previous line. We calculate the size of the melody array of the underworld melody of Mario theme. As you can see here, we have the underworld melody array variable and the underworld melody tempo array variables. Next, call the play tone function again to play the melody notes of Underworld Mario theme. Input the needed parameters, which are the Underworld Mario theme melody notes, melody note size, and the melody tempo. Click Upload, save the sketch as Mario theme, and click Save. So here we're fixing some syntax errors. Click Upload again. Make sure to connect the device and select the board type and the COM port. We upload again. But this time we have a melody problem because I forgot to add the delay of the pause between notes. Let's go back to the play tone function and add the delay. So click upload again. Now you're done. You have created the Mario theme melody using the buzzer and the LED. Hey everyone, it's Nov. In this lesson, we will be making a game. This game is called the Reflex Game. The goal of this game is to test how fast our response time is by clicking the button. The components we will be using here are the OLED, the LED, and the buzzer. The OLED will be responsible in flashing when to press the button and also flashes the recorded reaction time. The LED and the buzzer will also signal together with the OLED. This indicates when the button will be pressed. The mechanics of this game is fairly simple. When the OLED displays go and the LED flashes along with the buzzer, the player must press the button. However, if the player pressed the button before the indicators were set off, then it will disqualify the player and the code runs again. So let's get started in making the game. The first thing is to prepare the Arduino Sensor Kit. Connect the Grove base shield to the Arduino Uno. Plug in the Grove button to the pin marked D4 in the Grove base shield, while the Grove buzzer connects to pin D5 and the Grove LED to pin D6. Then, connect the Arduino Uno to the computer, open the Arduino IDE, and proceed to create a new sketch. The first thing we will be doing is including the Arduino Sensor Kit library. Instructions on installing this has been mentioned in the Oled lessons. We then define our pins. In this activity, we will be defining 3 pins: the LED, the button, and the buzzer. The LED is set to pin 6, the button to pin 4, and the buzzer to pin 5. We then introduce a variable to store the random delay value. And add a real-time variable for recording the current time since program ran. We set the variable time response for the player's time response and the fastest time response for the player's fastest time response recorded. We also set the buzzer tone to value note AS4. Now go to the setup function and let us initialize the OLED display. To initialize this, simply put oled.begin. Set the OLED display orientation to rotate to 180 degrees by using the Set Flip mode to True. Also, to set the OLED font, use oled.setFont. We also set the pin modes for our LED, buzzer, and button. The LED and the buzzer being the output, and the button pin as the input. Now we create a start function. This is for the start of the game. Adding the code clear line removes the previous display from the OLED. So set the OLED cursor to the first character and first line. Then the OLED should print the instruction on how to start the game using the following codes. Next, we create a ready function. This is to signal that the player should get ready. So again, the clear line code here is repeated. We also set the OLED cursor to the first line and print the get ready signal. We then put a 1-second delay for every messages the OLED flashes for the purpose of signaling the player to get ready. This is done by using the clear line and delays. We proceed in creating a go function. This is when the game now instructs to push the button. So the clear line and the set cursor again are repeated. Then we introduce a run delay. What happens here is that you get a random waiting time for every round. Then, to check if the player pressed too early, we create a cheating function. This function is to check if the player pressed the button before the go signal even flashed. We use digital read to know the button state and place it in an if statement. Then we remove the previous displayed OLED values and set the cursor back to the first character and first line. If the if statement is satisfied, the OLED will print signal disqualification. Return true to stop the player to continue. And return false to continue the game. Now let's go back to the go function and add an if statement to check if player is cheating. If cheating is detected, the code returns false in order to reset the game. This is presented here using the if statement. The code also waits for 50 milliseconds to proceed. Then it turns on the LED using the digital write. It turns on the buzzer using the tone. And prints the go signal, go. It then gets the current time in milliseconds from time since program ran. So let's create a function to record the time. This function records the player's response time. When this function is called out, the LED and the buzzer turns off, and everything from the OLED will be removed. What's removed here is the previous messages displayed on the OLED. We set the cursor back to first character and first line and print time label to the OLED. We get the player's time response using the formula below. The time response is displayed in the OLED using the OLED.print, and we print this in milliseconds. We then call the function fastest time, which we'll be creating next. So to create the fastest time function, we type void set fastest time. Check if the time response is much faster to the previous recorded time response. This is going to be the fastest time response in the game. To do this, we use the if statement. We set the cursor to line 3 and print new recorded fastest time signal. We set the new fastest time response using the time response we got in the beginning, and we call the display fastest time function that we will be creating right after. So we create the display fastest time function. This is to display the fastest time recorded from the game. We clear line 7 to remove the previous fastest time displayed and set the OLED cursor to line 7. Print the fastest time label and print the fastest time response, also recorded in milliseconds. We then create the wait button function. This function will stop all running and will only proceed once the button is pressed. Now, in order to know the button state, we will be using digital read. So now go to the main function, which is the void loop, and call the function we've created in the following order. Start function, wait button function, and ready function. After this, we then use an if statement to set the actions done once player is ready to go. And when the if statement is satisfied, the wait button and record time functions are called upon. We add a delay of 3 seconds in order to proceed to the next game. And once that's done, save the code, upload it to your Arduino, and you're ready to play the game.
Now that is it for this lesson. To learn more about the other modules, simply head on to the next video.